Hi, everyone. Can you hear me? Hello, can everyone hear me? Say something in the chat if you can. Hi, okay, awesome. Thank you. Great, okay. Thank you all for coming out tonight for the stream for AP Calculus. I'm Megan Dwyer. I'll be presenting to you tonight. I know that a lot of you probably are going through having to take online classes right now, and so hopefully Fiveable can be a resource for you guys to help you get ready for the AP test even when we can't be in the classroom. So it's great to have you all here. If you have any questions, let me know, and feel free to let me know in the chat or along the way with the question part. So just before we start, let me share the slides with you that we'll be looking at today. Okay. So starting here, I already told you this, we're going to be talking about the Fundamental Theorem of Calculus and Integral Defined Functions. It's hosted by me tonight. And for all of you people who might be new to Fiveable and might not have seen this yet, this is what our streams look like. Here, let me make this bigger for you guys. There we go. This is how our streams work throughout the week and what we show based on the day we're at. So if you're in any other AP classes, feel free to join in any of those days. If you're unsure or you're of what's going to be playing, or if there actually is going to be a stream, then you can also take a look at all our social media at Think Fiveable. If you have any of these, this is a great way to keep track of what's going on. Awesome. Okay. So hi everybody. Thanks for responding in the chat. I will be asking you questions throughout it. You can respond in the chat if you're feeling comfortable. I would love to have you all responding as much as you can. Okay, so before I get started here, we're going to be talking about the Fundamental Theorem of Calculus. Can you show me in the chat, just with a yes or no, have you learned about the Fundamental Theorem of Calculus yet? Yes or no? Awesome. Okay, great. Mostly yeses so far. Wait a couple more seconds. Okay, awesome. Okay, great. So we've got different levels of comfortability. That's okay. We're going to talk about it a little bit. We'll review it a little bit, and then we'll jump into some examples on how to use it with integral defined functions. Okay, so there are two parts to the Fundamental Theorem of Calculus, and based on your book, you might know the two parts as something different. So we're going to review part 1 and part 2, and then we're also going to review some strategies for using it on the AP tests, and then we're just going to practice for the rest of the time. Get you guys some good AP level questions that you can rely on for studying for your test. Okay, so according to the book I use, part 1 has to do with a definite integral from A to B. And part 2 is somewhat of a definite integral. It just has a variable as one of its bounds. But if your book says it's in a different order, that doesn't change anything about the fundamental theorem. That's okay. I just put it in this order because I'm actually going to use the first part to explain the second part. Okay, so in both of these, part 1 and 2, both of these functions have to be continuous. I'm just answering question. Derivatives and integrals are opposites. Yes, essentially that's what the fundamental theorem of calculus is telling us in general, that a derivative and an integral can kind of undo each other. I have that as part 2 on mine, but yes, sometimes that's as part 1. Will you need a calculator? I have a calculator and I will do out the math. Yes, some of these are calculator questions. So if you have a calculator, it would be great to have one. If not, I will explain the answer and tell it to you. But yeah, using a calculator would be helpful right now if you want to do the problems all the way out by yourself. Okay, so it's important in both parts that your function f, it has to be continuous. And we use a capital F to represent the antiderivative. Have you guys seen that? Capital F for antiderivative. I hope if you've seen the fundamental theorem, you have seen that already. So I will do my best to remember to say capital. And then for lowercase f, I'm just going to say f, and I'll say antiderivative of f for the capital F. Okay, so part 1 If f is continuous on the interval a to b, and capital F, or is the antiderivative of f, then the integral from a to b of f of x dx is just f of b minus f of a. Okay, hopefully you've all seen that before, at least a little bit. We'll explain it in a second. Part 2, again, f has to be continuous, a continuous function. And if you have a, your lower bound is a constant a, and your upper bound is x, then if you take the derivative of that integral from a to x of f of t dt, you end up just being left with f of x. Okay, so we'll talk about that too, but that's really the part that says that the derivative and the integral kind of cancel each other out. They're opposites of each other. Okay, so let's look at the first part. So these slides are going to be available to you afterwards on Fiveable. Feel free to write them down as notes if you want. It might help you to remember it, but you don't have to. Okay, so this is some of my handwriting. I did my best to make it as neat for you as possible. So talking about the first part of the fundamental theorem, if we take a look at this graph here, we've got a line here, and that line, that curve represents f of x, okay? And on f of x, I've drawn two different x values, a and b, and we know that an integral, in other terms, we could say represents the area under the curve, okay? So if you want the antiderivative or the integral of f at a, then you're essentially saying take everything up to a, and that's under the curve and between the x-axis, and that is what the area of a will be, and that is my integral at a. Same thing with b. We take the area under the curve for b and everything before b, and that would be our integral at b. Now, if we want the integral from a to b, then we just have to take everything that was the area at a, subtract that out of b, and we're left with what's between a and b. So f of b minus f of a gives us what's in between them. Does that make sense? Any questions on that? We're looking for an area between a and b. A is smaller than b, so if we subtract a's area out, we end up with the area between a and b. Any questions? Okay, great. Okay, so we're going to use this to explain the next part. Okay, so part 2 we have of the fundamental theorem. Okay, you'll see it in a second. So at the top there, we've got the derivative of the integral from a to x of f of t dt equals f of x. Okay, so I'm going to go inside out. I'm going to start by taking the integral from a to x of f of t, and I'm going to use the first rule that we just learned, part 1 of the fundamental theorem of calculus, and that's going to become antiderivative f of x minus f of a. Okay, so that we use that first part that we just learned, but we still have to take the derivative of that. So when we take the derivative of two things we're subtracting, we can essentially take the derivative of each separately. Okay, so we've got the derivative of f of x minus the derivative of f of a. When you take the derivative of the antiderivative of x, what do you end up with? Feel free to answer in the chat if you know. So we've got an antiderivative and a derivative. Yeah, we'll get the original function. Good, Dylan, thank you. But what is f of a? If we take a, which was a constant, and we plug it into our antiderivative f, we're just going to get another constant there. So f of a is representing a constant right now. If we plug f of a in and we take the derivative, what are we going to get? 0. Awesome. Thank you, Pascal. Okay. So awesome. So good. So if we take the derivative of antiderivative f of x and we take the derivative of f of a, we end up with f of x. We ended up back where we started. Awesome. Great job. And that's the second part of the fundamental theorem of calculus. This part kind of sneaks up on you in problems. So they'll give you some information. They'll give you a function in terms of another integral. And if you don't know this rule, it's really hard to solve the problem, or nearly impossible. So this is really helpful. Do we have any questions on this second part? Okay, great. All right, next, let's just go over some strategies for solving it. So like I just said, a lot of times they'll give you a function in terms of another function with an integral, okay? So it's your job when you're first solving these problems, one of the best things for you to do first is to just write out all the relationships you have between each function. So what is f and what is g? Is there any way to relate them? And do we have any other functions involved? Sometimes it'll even give you 3 functions. We'll do a few problems where there's 3 functions, okay? The next thing we want to do is figure out what it's actually asking us to find. So sometimes it'll give us a ton of information and we really only need a little bit. It could give us an entire table of values and we only need one value from one column in the table. So it's really important that we're focusing on what we're looking for and not just taking in all the information and getting overwhelmed by it. And then next, we're going to use the information given to figure out the best way to get the answer you want. So sometimes there'll be multiple different ways to do it. You're allowed to do whatever way you want, whatever you're most comfortable with. I'll be doing the way I'm most comfortable with tonight, but if you have other options, feel free to add them in the chat. That would be great so we can share our ideas. Any questions so far? I'm going to keep asking you this, so it's okay if you don't have any. I just want to make sure. And feel free to ask anytime. Okay, awesome. So if we're good, I'm going to switch over to where I can write notes on the practice problems, and we're going to practice. All right, hi, everybody. Let's switch over here. Okay. Let's see. Can you all see the problem on the screen and the like whiteboard looking page? Are we good? Awesome. Okay, great. So this is the problem we're going to start with. Take a second to take it in and read it. I'll be doing it out on the page, but I just want to make sure I give you guys a second to start so you have time to try it on your own. Okay, so we're going to use actually both parts of the fundamental theorem of calculus here. I've got one of the parts up here, but we'll end up using both. Okay. Selected values of the twice differentiable function f and its derivative f prime are given in the table. What is the value of the integral from 0 to 8 of f prime of x dx? That is f prime of x if you can't see it. Okay, so the first thing we need to do is find the integral, right? So using this first rule and the second rule at the same time, if you're taking the integral of f prime, what could someone in the chat write out what that equation would look like? What would that be in equation form if we're taking the integral of f prime? Okay. You do not have to write out part 1 if you're solving it. It's implied that you know it. Good question, Dylan. Okay. Okay, so one thing you've really got to pay attention to here is that if we're taking the integral of f prime, another way we could write this, right, is that we're taking the derivative. Oh, hang on one second. Okay, the derivative from 0 to 8 of the integral, right? So what's happening here is that we've got f prime in here already, f prime, and we want to make sure that when we take the integral of this, that we don't forget that it's already a derivative, okay? So let me erase this here. If we've got the integral from 0 to 8 of f prime of x dx, don't forget our dx, the integral of f prime, if this is already f prime, will be what? F of x. Good, Tucker. Good correction there. So this is going to be f of 8 minus f of 0. Okay, lowercase f, because we've got the integral of f prime. Okay, f of 8 minus f of 0. We go over to the table down here. F of 8 is 23. F of 0 is 5. So we get a final answer of 18. Okay. Any questions on that problem? The prime is sneaky. You've got to make sure you notice it, and you can't. If you forget that it's prime, you might end up using the wrong column in the table. And they gave us this entire table of values. We only needed 2 values out of it, and we didn't use the f prime column at all. It wasn't necessary. All right. Okay, going on to the next problem. Let f be a differentiable function such that f of 0 equals 3.256 and f prime of x equals x minus cosine of x. And then it says, what is the value of f of pi? Okay, so this one you're going to need your calculator for. This is a calculator question. Calculator, okay. So there's a few different ways you could go about this. Does anyone have any strategies they have? This one is not a differential equation. Yeah. We're given f of 0. We're given the derivative, and it asks us to find f of pi. Okay, well, what do we know? We know that in order to find f of pi, we're going to need the function, and all we have is the derivative here. Okay. So let's think about this. Let's write this out. We know that the integral from, let's say, from 0 to pi, because pi is what we're looking for, of f prime of x dx is going to be f of pi minus f of 0. Yes? Agree? Okay, good so far. So then, since I've got that already, I've got f of pi right here. So if I can solve for that, then I'll be good. So what I'm going to do is I'm going to take f of 0 and move it over. Move it over to the other side. Okay, and we end up with, no, let me change that back to black. F of, sorry, this should not be x, this should be 0 right here. Okay. F of 0 plus the integral from 0 to pi of f prime of x dx equals f of pi, and that's what we're looking for there. Okay, awesome. Okay, so if we've got that, this is where your calculator is going to come in handy, because we don't know, or since it's a calculator question, we don't really need to find the integral from 0 to pi of f prime of x on our own. We can use our calculator. So we've got f of 0 here, which is, what was it again? 3.256. Plus the integral from 0 to pi. And then f prime of x was x minus cosine of x dx. And if we can find that, we will get f of pi. Okay. Now let's use our calculators. Can anyone find that for me? Also, just always a good reminder, how many decimal places do we need to round to on the AP exam? 3 decimal places. Good. Thank you. 8.191. So Pascal, that was them already added together, correct? Do we have the integral? Awesome. What was the integral itself from 0 to pi of x cosine x? (3.256) plus, is there anyone who does not know how to use the integral feature in their calculator? Okay, good. Okay, so we've got 4.935. Good. That's what we've got, 4.935. And we end up with approximately 8.191. That's our final answer here. Okay, any questions on this one? Okay, good. Okay, let's go see our next problem. All right, now we're getting into using the other part a little bit more. This has 3 different functions it's going to have us look at, so we need to make sure we're keeping all those straight. So we've got f, the function given below, which is the integral from -2 to x of g of t dt. And just a hint and a reminder, whenever you see this x here, whenever you see an x as an upper bound, you should be automatically assuming you're probably going to have to use this rule. It's probably going to come up right away. So just keeping that in mind, let's keep going. Okay, and it says where g is a differentiable function. Oh, also, let's go back, think for a minute. Remember I said that when we were talking about the fundamental theorem, that both parts of the fundamental theorem required that the function f be continuous. So I haven't really talked at all throughout the problems of knowing that the function is continuous, but have they all been continuous? What have we noted, especially in this problem, so since we're looking at this problem, do you know if this function is continuous or not? Yes, why is it continuous? Good, since it's differentiable. So automatically when you see the word differentiable, you should know it implies continuity. Anything differentiable is continuous, but just because something's continuous doesn't necessarily mean it's differentiable, but that's okay because all we need is continuous right now, so we're not too worried about that. Okay, so we've got this upper bound x, we know it's differentiable, so we know it's continuous. The table above, sorry, it's below, I moved it below, gives the selected values for f, g, and g prime. If h is given by the other function below, for which of the following values of x is h of x equal to f prime of 3? Okay, so they've given you a ton of information here. They've given you f and g in terms of each other. They've given you h. They've given you a table of values for f and g prime. But then at the end, they ask you, when is h of x equal to f prime of 3? So we're looking for what value of x here, what value of x is going to make f prime of 3 equal to h? So any suggestions for where we should start on this? Derivative of f of x equals g. Awesome. Yeah, so you should be looking at this first function in the rule that we're applying to today. If you want f prime of x is going to be the derivative with respect to x of the integral from -2 to x of g of t dt. Well, we just learned this rule from the Fundamental Theorem of Calculus. This means since this is a constant and this is an upper bound of x, that means f prime of x is equal to g of x. Okay, good. So if we want f prime of 3, we're really looking for g of 3. Okay, g of 3 we can find. G is given in our table. 3 is right here. So if we look down, g of 3 is 4. So g of 3 is 4. And that means f prime of 3 is also 4. Okay, so now we know f prime of 3 is 4. What are we doing with that 4, though? How does that help us? We've got f prime of 3, and we're supposed to be finding when is f prime of 3 equal to h of x. So if we know f prime of 3 is 4, then we're looking for what? Okay, good. Yeah, we're looking for when is h of x going to be equal to 4. But h of x is given to us as x plus e to the x minus 2 equals 4. Okay, now again, this is another calculator question. Sorry, I didn't state that earlier, but once you get to here, this would be a kind of an ugly one to have to do out without a calculator. So this is a place where you can have a few different strategies for finding x. I have one, but I'm looking, what do you guys have for suggestions? How are we going to find out when those are equal? What are some things we could do? Okay, so I'll start off by telling you the way that I would do it in my calculator. So what I would do, and I have a TI-84, so this might look a little different for someone who has a different calculator, but I would take this and I would put it in one side of y equals. I would put it in y1 in my calculator. And then I would take this and I would put that in y2. Okay. And what's going to happen when you put those in y1 and y2 is you're going to find their intersection point. It's going to show you where they intersect on your calculator. And that way you'll be able to find where they intersect, and that'll tell you when they're equal. Okay, so let's put it in y1, x plus e to the x. This is good practice. If you have your calculator, you should do it as well. And 4, we set those equal in graph. Okay, so you should get a graph that looks somewhat like this. We've got, this is our function h of x. And then we've got a line here at 4. And you're looking for this point here, this point right here. Okay, so you can do, in my calculator, it's second trace, intersect. And we get about 1.503. So we get x is approximately 1.503. That is the x value we need in order to make h of x equal to f prime of 3. So what this is saying is h of 1.503 is going to be equal to f prime of 3. That's when they cross. Good, awesome. There's also, in some calculators, there's a solve function. And if you type either side of the equation into the solve function, you can find where they're equal. It'll just tell you x. That's a really nice function. The Inspire has that. I haven't worked much with Casio, so if you have a Casio, I would suggest looking it up on the internet. Usually, if you just type in how to set things equal on your calculator and you put the calculator brand in, it'll show you right away online. Okay, any questions? Okay, don't forget you can ask them anytime in the chat or ask a question. Okay, we'll go on to the next problem. All right, so this time we have a graph, and we have a graph and it shows us a function that's differentiable. Again, it makes sure to tell us it's differentiable, and a line that's tangent to the graph, and it's tangent at the point 3, 4. So we know that this point right here is at 3, 4. Okay. F is the function given below, and h is the function with the first derivative given below, and that first derivative we're using from 0 to 8. In the graph, it looks like the graph is showing us 0 to 8, so that's fine. There's no really problems there. If the line tangent to the graph of h at x equals c is parallel to the line tangent to the graph of f at x equals 3, what is the value of c? All right. Where to start? Any suggestions on where we should start? It's too small? Okay, let me make this bigger for you. Is that better? Yeah. Let me just get that and I'll make it bigger. Can you see it better now? Okay. Good. Hopefully that's good for you guys now. Okay, so we've got a function. We've got h prime. What can we do with those if we want to know what value of c is going to make h parallel to f? Okay, so the graph, while it's important to have a visual, it's actually, you could, even if I didn't put the graph there, we would be able to solve this problem because of the information it's given. So let's focus in on what it's given us so far. For we've got the graph of g in a 0.34. Okay, so we need that 0.34. That's the real important part of this graph. This is really the only part you need. Okay. Okay, so we've got a point, and whenever you're given a function that's in terms of another function with an upper bound of f, you automatically want to start and make that connection again, that f prime of x is going to be equal to g of x, okay? We found that on the other function. We've got a constant as our lower bound, x as our upper bound. So we've got this connection here that f prime of x is g of x. So now that we know f prime of x is equal to g of x, we know we're talking about something being parallel, and we're talking about tangent to the graph, okay? So when we're talking about things being parallel, what does that mean? Same slope, exactly. That's what we care about, the same slope. And we know slope in calculus is a derivative, right? So if we have the derivative, we want it to be parallel to that. So of f at x equals 3. So we want f prime of 3 to equal h prime of x. It doesn't tell us, but we know we want their slopes. This is the slope of f, and this is the slope of h. Okay, and we want them to be parallel, which means they have to have the same slope. Okay, so if we can set their slopes equal, we just need to find this x value here. Okay, so we start by finding f prime of 3, and we can't find f prime of 3 without this relationship here, okay? So we've already done this out here using the fundamental theorem. F prime of x equals g of x. So we've got f prime of 3 is really g of 3. Do we know what g of 3 is? Four, exactly. So that's all we needed was that point. We've got g of 3 equal to 4. And so we know g of 3, we know that's f prime of 3. And now we go back to what we needed here. We need f prime of 3 to be equal to h prime of 3. So we need 4 to be equal to h prime of x. And then got to pay attention to what we're given here. We're already given h prime of x. So this is not h of x, it's h prime. So h prime of x equals x tangent pi over 6. So 4 equals x tangent of pi over 6. Now this could go either way. This could be a calculator or a non-calculator question. In this case, we can use our calculators. And there's two ways to do this. Again, there's more than one, probably more than two ways. What I would do, I don't usually use the intersection part of the graph unless I absolutely have to, because I feel like it takes a long time. With this one, we could probably solve for x a little bit easier, okay? So if we just divide by tangent of pi over 6, divide by tangent of pi over 6, put this in parentheses here, then we'll have x. So 4 divided by a tangent of pi over 6, we get, let me just check my work, 6.928. And then I should probably use approximately here, 6.928. And what does that x represent? Make sure we're fully completing the problem. That x is actually telling us what c should be in order to make h prime of c equal to f prime of 3. Okay, so again, it's really not, it's really, the fundamental theorem part is really only a small bit of it, but you can't really do, you can't really do the problem without knowing that part, okay? Yeah, exactly. The point on h where the slope of h equals the slope of f at 3. That's exactly right. Awesome. Okay, any questions on this problem? Use the fundamental theorem at the beginning, and then from there we just got a lot of algebra to do and some interpretation. Okay, let's go on to our next problem here. 11. Is that the next problem? Make sure I didn't skip one yet. Okay, awesome. A hose allows for gas to be pumped into a car at the rate R of t, sorry, that should say rate, R of t equals 1.5 liters per minute. But even though it doesn't say rate, we know it's a rate because it says liters per minute. So then it has to be a rate. Okay. Where t is the time in minutes since the hose was turned on. Write a function that measures the accumulation of gas in the car's tank during the period t equals 0 to t equals x as the variable x moves along the t-axis. Okay, so that's just telling us that time in x is telling us about the time here. Okay, so all you're doing here is writing a function using the rate. Okay, I'm going to give you guys a minute to try to write this function because this one doesn't actually have much work. Okay, so feel free to ask me any questions, but I'm going to pause for a second. If we've got a rate and we want to know how much gas measured is in the tank, the accumulation, but we have a rate. Okay, good. Anyone else want to add to that? Do you guys agree with Dylan? Okay, I think it looks good. Let's take a look at it. So this is liters per minute. So as Dylan said, we've got L of t, our liters. That's going to be equal to however many liters we have is going to be the integral from 0 to whatever time of our rate with respect to time. Yeah, that's about it. So they give you all this information to tell you you really just only need to take the integral of it in order to find the accumulation. So whenever you're given a rate and the rate is asking you to find, they give you the rate and they ask you to find how much has built up or what's going to be left after this certain amount of time, you're really just finding the integral of that rate. That'll tell you how much you have, okay? That one, the only real place the fundamental theorem is applying is that your upper bound is x. Besides that, it's just a interpretation problem. All right, let's go to problem 12 here. Okay. I'll make this a little bigger for you guys. There's a lot of words here. So the problems we've been doing so far have been multiple choice questions that I just didn't give us the multiple choice options to so that we could practice finding the answer without the multiple choice. However, this one here is it's one part of a 4-part multiple choice question. So I've given you all the information you need to just solve this part, but make sure on free response questions like this, you're writing out everything you can think of. You should write out all the steps. Even if you say by the fundamental theorem of calculus, you use this, that's a really great way to show AP that you know how you got to the part you're at. So I'll give you guys a second to do this one and we'll talk about it. Okay, so we've got a table. We've got this function, T of X, it's measuring temperature in Celsius. And we've got a distance that glass. So we've got a glass blower has this piece of glass and he's heating it at one end. And the length of the piece is 10 centimeters. Okay, we're stretching out this glass piece to 10 centimeters. So as the distance stretches, as we're farther away from the point of heat, the temperature gets cooler. Okay, that's what this table is telling us, that if we're 10 centimeters away from where the glass blower is putting heat, we have dropped to 45 degrees Celsius. Okay, so find the integral from 0 to 10 of t prime of x dx. So based on what we've learned so far today, what is that integral going to be? the integral from 0 to 10 of t prime. Remember what we're talking about, what this lesson was on, Fundamental Theorem of Calculus. Okay. All right, well, I guess I'll go. All right, Dylan, you should feel good about that because that's exactly how you find it. So if you have an integral from 0 to 10 of t prime of x, the integral of the derivative is just going to end up being the function itself. Okay, so this works because we've got an integral of a derivative. So that's the whole point of this, is by the fundamental theorem of calculus. So on a free response question, I would probably write this: by the FTC, the integral from 0 to 10 of t prime of x dx has to equal t of 10 minus t of 0, because we've got t prime here. Okay, so it feels really easy. That's kind of how they're trying to get you to make sure that you can interpret it. You don't really need to find t prime because you already know what it is. You've got t. Okay, t of 10 is 100 minus, oh sorry, t of 10 is 45. Looking at the wrong side of the table. 45 minus t of 0, which is 100, and we get negative 55 degrees Celsius. That degrees Celsius is important because it says indicate units of measure. If you didn't do degrees Celsius, you probably wouldn't get full credit here. Okay, so negative 55 degrees Celsius, and then it asks us to explain the meaning. Okay, so we had t prime. Okay, let's start with that. What is the meaning of t prime? Well, T prime here, if T stands for temperature, then T prime, we'll just put this off as a side note here just to help us with our interpretation. T prime is going to be the rate that the temperature is changing. Okay. And so if we have the integral from 0 to 10 of t prime, we get negative 55. What does that negative 55 represent? Without this explanation, we can't have change in temp over change in time. So we're on the right track. We want to write this out kind of in words using the negative 55. Okay, so what we can say here is that the difference actually, let's not start with the difference. The temperature, sorry, I'm bad at writing on the board in the classroom too. The temperature decreases by 55 degrees Celsius when you move 10 centimeters away from the heat. Okay, and you might be looking at that and being like, well, yeah, I could have told you that, I know that, but they're looking for you to be able to do the math first and then explain that and be able to interpret what you're looking at. This is one of those problems that might get you because you think it's a lot more complicated than it is. So make sure that using the fundamental theorem of calculus, it's a pretty simple thing to use, but it's so important because it helps us solve problems that probably look a lot harder on other terms. Okay. Okay, give you a second to write that down. Good, awesome. I'm seeing good interpretations coming in now. So the integral of a derivative, the only way it's useful in a real sense is to help us know that if we take the integral of a rate then we end up with the amount of whatever we had. So if something's accumulating, it tells us what the original function is. So if we've got a derivative and we integrate it, we can find out how much has accumulated, or how much we've lost. So for example, last year there was a problem, a cone problem, I believe, where the cone was being filled. And you know the rate at which the water is going in, but if you want to know the water at a certain amount of time, then you integrate that rate and you can find out how much water is in the tank at any given time. Thank you, Jerry, for answering Abofu's question. Yes, you should always use units as much as you can. When it comes to free response questions, the more description you use, the better. And what I like to say is even if you weren't sure on an answer, if it has units in it, if you remember to write the units on your answer, you can almost guarantee yourself 1 point. So make sure you're always putting the units on your answer, because that gives you a starting place where you know you've got something on the problem that you've done correctly. All right, I'm going to make sure I answered every question. Okay, looks good. Okay, let me share the PowerPoint with you again. And let's look back. All right, so let's look back here at the fundamental theorem. So these are the two things that were the focus of tonight. So you really need to make sure that come AP time, you know these two parts of the fundamental theorem of calculus. Again, it doesn't matter part 1 and part 2. They really don't connect in any way that it matters. You can use them to prove the other. So that, I guess that would be one way where it matters, but come test time, you just need to know them both. And they really come in handy a lot, and we get to a point where we use them without thinking. But again, on an AP free response question, it's pretty important to make sure you write out all your steps. So if you write out by the fundamental theorem of calculus, it's kind of helpful for you as a check to remember you're writing everything out. And AP, sometimes writing out something like that can be a point for description. Any questions on either of those right now? Feeling good? Okay, awesome. All right, so you've got those two parts. We've proved them tonight. We went through all of our, let's look at these one more time, our strategies, and then we'll be done. Okay, so again, we're making sure we're writing out the relationships between each function. So in this one, the really important part to write out on most of our problems was that our derivative of one function was equal to another, because we knew one function was equal to the integral. If we derive both sides, we get a new relationship. So we need to make sure we can move between those relationships freely. Yes, so Dylan just asked if you get the right answer, but you haven't really done everything out the way College Board wanted it, will you get partial credit? It depends on the problem. Yes, most of the time there is a point for the answer. So if you had written out nothing and just put the right answer, you would get a point. But a lot of times there's other points for other parts of the problem and doing your work out. So make sure you are writing out your work for each part of the problem as much as you can. They don't ever take off points for having too much work or something you're not supposed to put on there. As long as you've got the right things and you're organized and they can follow your work. Try not to put anything unnecessary, but if you have a little too much, it's better than not enough. But the answer isn't full credit. If you just gave a number as an answer, you wouldn't get full credit. Okay, so we figured out the functions. Then you need to think, what am I looking for? How do I get there? I think one of the most difficult problems we talked about tonight was having to find the parallel lines when we were talking about tangents. So whenever I see parallel and tangent, I always think slopes and same slopes. So make sure you're going back to those algebra words that you know, like area and slope. Describing the problems in terms of those words can really help you to simplify and break down the problem so it works for you. And then use what you're given, which a lot of times is a lot more information than you need to find the final answer that you want. So you're not really always going to need everything that they've given you, especially if they give you like a table or a graph. Like the problems I gave you tables in, we usually only used 1 or 2 values. And the graph problem, all we needed was a point. We would have been able to do it even if I hadn't put the graph there. So the visuals are helpful. Sometimes it helps you to be able to draw on it or see it in a different way, but they're not, sometimes you might be reading too much into it if you're focusing really on all the information given. Yes, Linda, great way to put it. It's a calculus test, so they need to see calculus. Make sure you're using calculus. In the free response questions, if you only use the word slope and area, that wouldn't be great. But if you're using those to help you understand it, that's fine. Make sure you're writing out the calculus parts when you're writing out the free response questions. Okay, and then we went through all of these practice problems, and that's it for tonight. Does anyone have any more questions on the AP test in general or on the fundamental theorem? Okay, well, if you think of any, feel free to message Fiveable. We'll definitely get back to you as soon as we can. And feel free to tune in next week for another calculus video. That'll be by me too. But there's plenty of streams throughout the week. As one last thing, why don't we look at the different days that we have streams? Okay, so take a look at Tuesday nights. You could have human geography, psychology, or U.S. government. So if you're in any of those classes, feel free to join in again and come out. I hope you guys found this helpful. And I was happy to be with you tonight. And remember, at any point after this, you can access this stream. So if you didn't take any notes or you want to look back at this, at any of the problems, you will be able to. All right, awesome. Thank you all for everything. Have a great night.